So let's continue with solving logarithmic equations, but this is going to take us in a different track. So I'll put this one in a different video because it's kind of a different idea. Up until now, we've had one log. Well, now we have two. Okay, well, we know, hopefully remember, the properties of logarithms that say that if I have two logs, I'm adding them together, then I'm really going to just multiply those two things and make one log. It simplifies things, it condenses it. So right now you look at that and you're like, man, that's a lot. Put it together. We're going to put it together by saying, well, log base 7 of x plus log base 7 of 2 is really log base 7 of, x times 2. That's 2x. There you go. And that's equal to 3. And now we're back to the very beginning of the lesson where we could solve this just by grabbing a calculator and doing it. So 7 to the third equals 2x. We turn it from log to exponent. Sometimes you can't turn it from logarithmic to exponential form first thing. You have to kind of condense and move things around. So 7 to the third equals 2x. So 7 to the third is 343, and that's equal to 2x. And then we'll just divide. And when we divide 343 by 2, we'll get a number that I should be able to find in my head, 171.5. And I'm going to feel ridiculous if that's wrong, but it is indeed right. So we're good, 171.5. So when we get to the next problem, when we flip the paper over, we see the next problem, we're going to see it's the same problem, but instead of plus, we have minus. So the process is going to be very similar except for the very, very beginning. So let's change this to a subtraction right there. And then we'll proceed. I accidentally erased part of the original problem. That's okay, I know what it says. So subtraction with logarithms means, oh my goodness, I can put them together and I'll divide. So log base 7 of, x divided by 2. And that's equal to 3. So 7 to the third equals that. So 7 to the third equals x over 2. Well, I still find out what 7 to the third is. 7 to the third is 343, and that's x over 2. The way to get rid of division is with multiplication. So times 2 here, times 2 here. 686 is equal to x. So again, same kind of process, we just had to divide at the very beginning. Okay, we get to the next problem, and we encounter a problem that we've not had to deal with before. And I had said something very vaguely in the previous lesson, or previous video, on the same lesson, sorry. And it was about dividing. And so here it goes. If I look at that, I might say, well, let's divide by 2. Do not write what I'm about to write, because it's going to get us into a mess, okay? If I divide this by 2, then I have to divide this by 2 and this by 2. And that's okay here, and that's okay here, because that takes us to 1.5, and this takes us to log. Don't write this, please don't write this. Minus, but then this is, what am I doing? Now, don't cancel these 2's, that's just illegal. That's a 1, so I have a 1/2 log base 7 of 2. Okay, so 1/2. Here's the problem. If I'm going to divide this 2 to get it out of the way, then I still created another coefficient, and that really didn't help. So creating a coefficient is very, well, inefficient sometimes. So I really don't have much of a choice about what to do with that 2. I'm rhyming here. I don't have much of a choice about what to do with this 2 right here, except to simply use the things I know about properties of logarithms and say, well, that's really an exponent. So log base 7 of x squared minus log base 7 of 2 equals 3. Okay? Well, we're back to where we started, where I'm looking at this and saying log minus log equals log minus log, divide. So log base 7 of x squared over 2 equals 3. All right, cool. 7 to the third equals all that stuff. 7 to the third equals x squared over 2. 7 to the third is 343, and that's equal to x squared over 2. I'm running out of room. I'll multiply both sides by 2. Times 2 here, wipes that out, multiply by 2 here, 686 equals x squared, and now I'm at a loss without a calculator, because the only way to find out what x is to take a square root, and the square root of 686 is, I like 3 decimal places, that's just what I do. So 26.192 and that's equal to x. There we go. All right, so when we see the next problem, we see a couple logs, and our mind might go in the same direction, but it's actually going to be different. So let's erase. And we'll do this. Log, this one's much easier than you think, but 2 plus x equals log of 3 minus x. Okay, so you might look at that and say, well, you know, log plus a log is multiply, and log minus a log is divide. And I hear you, but these are equal to each other. So you have this beautiful thing you can do, and let me give you the oversimplified version. You can just, you drop your calculator. You can also cancel out your, cancel out your logs. It works. Now, the reason that works, you don't have to write this step, is there's a 10 here and there's a 10 here, and there's this really cool thing where if I say 10 to this side equals 10 to this side, then these cancel when they're configured like that. And so basically you're canceling both logs. So if a log equals a log, as long as they have the same base, understood 10 on both of them, then just drop your logs. It's not a bad process. So we'll subtract 2 from both sides, cancel, cancel. So x equals 1 minus x. We'll add x to this side, add x to this side, cancel, cancel. 2x equals 1. We divide by 2. Don't be afraid to get a fraction for your answer. The answer is a half. Got it. Okay, so the next problem is almost exactly the same. We're just going to drop our logs. And we have to make sure they have the same base, and they do. On the next one, they have a base of 2. So we're just going to drop log base 2 from both sides. What about the 2? Don't worry about it. It got dropped. Log base 2 of 3x minus 7 equals log base 2 of what, 19? Yeah, 19. Okay, if you want to get technical about why this is a legal thing to do, then you could say 2 to this power equals 2 to this side equals 2 to this side, and you're doing the same thing to both sides, and when they're configured like that, it cancels them out. You could just mark out your logs and move on. 3x minus 7 equals 19. We're going to add 7 to both sides. 3x equals 19 plus 7. That's going to give me 26. We'll divide by 3, and I'm going to leave it like this. If you want to turn it to a decimal, you can. It's crazy repeating decimal, but I'm just going to call it 26 thirds. That's it. As gross as it is. So when we look at the next problem, it's almost exactly the same. And then when we look at the last problem, we have a problem. So next problem is one of those that I recommend you try on your own. So mute the video, give it a shot, glance at it. You've seen this type of problem before. Log base 3 of 4x minus 6. Log base 3, 4x minus 6 equals log base 3 of 10. All right, we're gonna, 3 to this equals 3 to this, so cancel, cancel. 4x minus 6 equals 10. Can we do this in our head? Let's do it. You add 6 to 10, you get 16. 4x equals 16. 4 times something gives me 16. It must be 4. Got it. Now we get to the hard problem. If you've been muting it, I recommend you unmute it now. However, if you had it muted, you didn't hear me say that. Okay, log base x. We've seen ones like this before. Of 9 equals 2 thirds. Okay, oh well, it's in logarithmic form. It's not log equals log, so don't mark them out. But we will say x to this power equals 9. So x to the 2 thirds equals 9. Now up until this point, if we had an exponent like this, for example, if I had x squared equals 9, I'd say, oh, well, let's square root it, and I'd square root it. I'd undo it. Well, how do you undo an exponent of 2 thirds? Well, you could take the 2 thirds root. Don't complicate your life. Please don't. And there's all kinds of ways of thinking about this, but my personal preference, and I think this works really well, is you can raise it to the reciprocal power. Okay, check this out for a second. 2 thirds times, flip it over, 3 halves is equal to, well, cancel, 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 cancel. Everything went into itself 1 time is 1, right? That's what I'm aiming for. I want an exponent of 1, so we're going to raise this whole side to the 3 over 2, and we'll raise this to the 3 over 2. And when we do, we're going to have, well, whatever 9 to the 3 over 2 is, and we can grab a calculator in a minute, but not. But over here, if you have a power to a power, you probably learned this back in the day, you'd multiply, and those cancel, and I have x to the 1, and that's what I wanted. Okay, so let's figure out what this is, and let's not use a calculator. It's good practice. This is really the square root of 9, and then we cube it. Well, the square root of 9 is 3, and then we cube it. 3 cubed is 27. So this was a problem that wasn't as much about logs as it was about solving. But almost every time you see a logarithmic equation, turn it into exponential form. The exception is log equals log. You can just mark out your logs.